Okay, so welcome back. Today we're going to talk about a fairly common engineering and software development concept that you may or may not have heard of, and that is the concept of state machines. And that may sound kind of complicated and difficult, but what we're going to do is we're going to use a very simple example like you see here on the screen to help you to understand what is a state machine, and more importantly, why are they needed? What do they do? How are they implemented? And what we're going to do is we're going to take this example of an intersection and we're going to see how we might design a control system to control the traffic lights as you see here. Each lane coming into the intersection sees these traffic lights, and the light can be either red, which means stop, green, which means go, or yellow, which means, hey, if you're going, you need to slow down because the light's going to turn red and you're going to have to stop. So what we're going to do is, without any other resources, without, copying and pasting somebody's code or looking at details on how these things work, we're just going to think about what we know about how these work, and we're going to come up with a conceptual design based on what we know, and ultimately we're going to use that conceptual design to write an application that actually simulates the operation of these lights and how they would be controlled. So let's take a look at some of the basics of how this works and then start to think about, based on what we know, how to come up with a conceptual design. Now, it's not going to be 100%. Again, I don't know exactly how these work, but I do have a pretty good idea of some of the basics, and we can put that together, and then in the end we can fine-tune it and make it work more like the actual controllers. So let's take a look at what you could call state of the traffic lights, and that is where the horizontal lanes have a green light, which means any traffic in this horizontal lane can go, whereas the intersecting lanes have a red light and they can't go. So that could be viewed as a state where all of the lights agree that these guys have to stop and the horizontal lanes can go. Now, as you know, it's really, really important that you don't get these mixed up. For example, you don't want to have green lights on the horizontal lanes and this one light ends up being green also instead of red. This guy will think he can go and he might get into an accident. So it's really, really important that we have fixed states where all the lights are in known fixed conditions for everything to work. So the first one is we got the horizontal lanes can go and the up and down lanes can't. The next thing is these guys are going and they will get a yellow light after a certain amount of time. There's a time delay. And the yellow light will say, okay, you guys are going, but you're going to have to slow down and stop because these guys are going to get a green light and you're going to get a red light. So the next state is red on these vertical lanes and yellow on the horizontal lanes. And then the next state, of course, is the horizontal lanes have to stop for a red light and the vertical lanes have a green light so they can go. Again, these have to be exact. You can't mix and match. And also there are some timers involved to make sure that you allow enough time for the traffic to pass and before you switch to the other state. And then the next one is, now these guys are going, they're going to get a yellow light to have to slow down and stop. And then the final state is we're back to the initial state where the horizontal lanes can move and the vertical lanes are stopped. So how would we implement this? Well, we could, as we said, we could view it as specific states of all of the lights. And you want to make sure that all of the lights are in a desired state. You don't want to mix them because then you can get into some accidents, right? So let's say state 1 is where the horizontal lanes can go. State 2 is when you've got yellow lights on the horizontal lanes. State 3 is when the vertical lanes have a green light. And then state 4 is when they get a yellow light. And then we're back to state 1 where the horizontal lanes get a green light. So you can start to see there is some sort of machine controlling these lights. And one of its main tasks is to make sure that the lights are in those certain exact states, not any variation, but they have to be in those exact states. And there have to be some timers controlling all of this so people have time to stop, people have time to pass, and so on. So you can see we have 4 states that we have to control with our controller. Now, also, you may be aware, here in the US at least, we often have what are called occupation detection sensors on the lanes. So, for example, let's say we have red lights to these vertical lanes. You see the red lights, and we got traffic flowing on the horizontal lanes. You could set up this controller so that if a car comes on this vertical lane and stops, this sensor would say, hey, there's a car here. Maybe we need to change the lights because we haven't had any cars here. These guys have been passing horizontally. This sensor will be able to change the controller and say, hey, let's give these vertical guys a green light because they're starting to get some traffic. So these occupation detection sensors are another consideration in our controller where our states can be changed by these sensors. So there's going to be some logic that might change the different states or change the timers so that instead of waiting a minute for one, it'll do it quicker. So the lights have allowed states. The lights also have timers that control them. The occupation sensors can affect the timers. Also, you've probably seen where we have turn signals. We have additional signals that say, okay, everybody's going to stop, but the people turning have a green light. So there may be turn signals that add more states, more lights, and more timers. And again, it's very, very important you don't mix the states. You have to have very specific states where all of the lights agree so that you don't get into accidents. So these are some basic concepts we're going to have to think about if we're going to design a controller to make sure we have these allowed states and we have some timers and we have some outside sensors that might affect that. So let's take a first shot at a conceptual idea of how our controller might look. Well, let's say we've got a controller, and you could call it a state machine because it's dealing with states, right? You have to put the lights in certain states at a certain time, and it has to be exact. So we'll call it a state machine. That's just mumbo jumbo. That means what we just said. You've got to control the states. We also have incoming occupation sensors that give more information to the controller that may affect the timing of these red, yellow, and green lights. And keep in mind, here we showed 3, but there's probably at least, if you've got 4 sets of lights at the intersection, there's actually 12 lights, 4 sets of red, yellow, and green, and then some turn signals. So this state machine is going to have to do controlling of all of those lights. It's going to have to take in the occupation sensor data, and it's going to have to control timers. So the primary goal of the state machine is to make sure you're only in the allowed states and then take inputs and outputs to control the lights. So our goal is going to be to start turning this conceptual idea of a controller or a state machine into what we can call pseudocode, or writing down what the steps of our controller are going to do. And as we've said many times in our videos, I've got over 420 videos on this channel talking about software development and engineering, and we've talked about how important it is to design and then write pseudocode. And once you've got that pseudocode, which is the basic steps, it's very easy to convert that into software code. And as we've said before, writing the software code is easy. It's this difficult design steps, especially if, like we're doing here, you're not doing any referring to outside resources or pre-existing code or documentation on how these traffic lights work. We're just doing from what we know. We're going to make a conceptual idea, and then we're going to make that into pseudocode with step-by-step on how we're going to do this. So in the upcoming videos, we're going to start converting this into pseudocode. And in the meantime, I encourage you to take this as a challenge to figure out how can I convert this into actual code, and what have we left out? Is there anything that we haven't considered that we need to add to this based on your knowledge of driving? Is there anything we need to add to this and include in our conceptual design? So I encourage you to spend some time and figure it out on your own without using any external references, and see if you can come up with a more specific design of our controller, also known as a state machine. So that's it for this one. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.